Okay, so here's the story on this question. I have a ball and it's in my hand and I'm going to toss it upwards. And its initial velocity is going to be 8.2 meters per second. The acceleration, you'll notice, is 9.81 meters per second. This is gravity. This is it's going up. Gravity is slowing it down. It's attracting the ball back down to the ground. So as my ball's going up, this 8.2 meters per second is going to decrease at 9.81 meters per second squared. We want to know what the velocity of the ball is at a half a second and at 1 second. Now we're going to look at our equations. I know I have, what do I have? I have my V naught is plus 8.2. That means it's going up, or increase, or yes, I'm sorry, going up 8.2 meters per second. We know our acceleration is negative 9.81 meters per second squared. And we want the velocity at this point and at this point. So we want our V final at a half a second and our V final at 1 second. So we'll start with a half a second. So we want V final at 0.5 seconds. We don't know that. And we want a V final at, oops, at 1 second. So what equations do we have that we can solve that? We don't have time and we don't have position. Let's see. So if we don't have position or time, this one would be challenging. Our very first one wouldn't really work. And our last one also involves position, so we can't use it. So let's go with our second equation. Our V equals V naught plus AT. Cool. So that's what we're going to start with, but let's also draw a picture of what's going on here. If I'm going up, and if I'm starting here, my V naught is at plus 8.2, and I'm going up into the air at that speed or velocity. Am I going to be in the air for, do you think, this full 0.5 seconds or this 1 second going up? Or do you think I'm going to be on my return trip at a half second or 1 second? Let's make sure that looks like a 1. So first, what do you think is going to happen? This is 8 meters per second going up. Let's see. So V final equals our V naught, our 8.2 meters per second, plus AT, so negative 9.81 meters per second squared, times our time. And we're going to start with the 0.5 seconds. So you'll notice a little quick unit analysis. This crosses out with that time, and we're in a velocity. So we get 8.2 meters per second plus, quick calculator work, 9.81 times 0.5, because if I'd been nice I'd have made that an even number, but I wasn't. So negative, don't forget the negative sign, negative 4.905 meters per second. Alright, so I have 3 sig figs here, I put 4 here. We'll go ahead and simplify that to 3 when we're all done. But meanwhile, we need to add these two. So I have 8.2 minus 0.4905, 4.905 equals 3.295 meters per second equals 3.30 meters per second. Okay, so we're still going up. Our speed is still in the positive direction. That means our we're still going up in this way. We haven't started decreasing yet. What happens at 1 second? Well, we're going to do the same here, except for now v equals 8.2 meters per second plus negative 9.81 meters per second squared times 1 second. I'm not going to use the calculator for that one. So what do we get? We get v equals negative 9.81 plus 8.2, and I will so I don't look silly, 9.81 minus 8.2. I get negative 1.61 meters per second. So at this point, at 1 second, we've decelerated enough that we've finished going up. This is the velocity slowing down. So it's left my hand, it's slowing down, it's slowing down, it's slowing down. It's going to approach 0 before it turns around, gets up high enough, and makes its return trip back down. The negative velocity, oh dear, how much of that couldn't you see? The negative velocity means that it's going now in the downward direction instead of up. The plus means going up, not increasing, because the acceleration tells us if we're increasing or decreasing. This is up or down. And we are going in the downward direction at negative 1.61 meters per second. So at what point do you think we hit 0? And how could we solve that? Sounds like a good question for Monday to me.